I've used computers for most of my life. I've learned how to program and build things with software. But recently I realized that I couldn't answer a very simple question. What is a computer, really? I know how to tell a computer what to do, but I didn't truly understand what was happening underneath. How does code become instructions? How do instructions become electrical signals? And how can billions of tiny transistors produce everything we see on the screen? So I decided to start again from the beginning and learn how computers really work, one layer at a time. And on this channel, I'm going to share the questions, difficulties, and discoveries I encounter along the way. Hi, my name is Sergio Pimenta, and welcome to my channel. One of the things I've always wanted to learn is assembly language. Some people describe assembly as the language of the gods. It was a reputation from being extremely difficult, as if learning assembly were the final boss of programming. I had also heard that learning assembly helps you understand how a particular processor really works. You begin to understand what the processor can and cannot do. Every processor architecture has its own characteristics, and assembly brings you much closer to the actual machine. I'm also a perfectionist, which has many disadvantages, and I've always been fascinated by efficiency. Waste and unnecessary bloat are the two my biggest enemies. And speaking of bloat, modern software can sometimes feel like a complete disaster. It was already becoming bloated before AI, and now it often feels even worse. I didn't live through the 1980s, but programmers had to squeeze every last byte out of computers such as Commodore 64. But when I was younger, I remember seeing keygens and crack intros with ridiculously small executable files. Some of them could generate codes, display animated artwork, and play music, all within a few dozen kilobytes, sometimes using less space than a simple Microsoft Word document. At the time, I didn't even know that assembly language existed. But the idea that people could create so much with so little stayed in my mind. And I think this contrast also explains why learning how computers really work can feel so difficult today. Modern computers are incredibly complex. A home computer from the 1980s was still an impressive piece of engineering, but it was small enough for one person to form a reasonable complete mental model of the machine. You could study its processor, memory, graphics, sound, and operating environment and begin to understand how most of the parts work together. A modern computer is very different. May have multiple processor cores, several levels of cache, virtual memory, a graphics processor, complex security system, firmware, drivers, background service, and an enormous operating system. And that is before we even consider all the layers of software running on top of it. All of those layers are useful. They allow us to build much more powerful and capable systems. But they also hide what is happening underneath. Trying to understand a modern computer directly can feel like trying to understand an entire city before learning how a single house is built. Perhaps this is why so many explanations seems to begin somewhere in the middle. Eventually, I started trying to learn assembly, but something always felt incomplete. So I decided go down another level. I started learning about logic gates and how computers are built from simple logical operations. Things slowly began to make more sense. Not completely, but for the first time, I could see some light at the end of the tunnel. Then I decided to dig even deeper. The deeper I went, the more the different pieces began to connect. I became hooked on learning out the foundations of computing, the ideas that explain not only how computers work, but what makes a computer in the first place. I've now reached a point where I believe I can start helping other people with what I've learned so far, but I'm still learning. That doesn't mean learning all of this requires no effort. It takes time, and I've spent many hours trying to understand these subjects. But I also discovered that part of the difficulty comes from the approach we use and the point from which we begin. Many explanations teach individual components without first explaining why we need them. I want to take a different approach. Rather than simply listing components, I want to begin with the abilities a computer needs and then discover the tools that make those abilities possible. My goal is that as we move through these concepts, your computer will gradually stop feeling like a black box. I will share the questions I asked, the mistakes I made, the explanations that confused me, and the insights that finally helped everything click. This channel is for anyone who wants to understand what is really happening underneath their software. For example, even if you program in a so-called low-level language like C, functions are still an abstraction. The CPU doesn't understand what a function is. As far as calling a function is concerned, essentially jumps to another address, executes instructions there, and then returns. By learning these lower layers, we can begin connecting the code we write to the physical machine that executes it. So, subscribe to the channel if you would like to follow this learning journey and understand, one layer at a time, how computers really work. And let's begin with the first question. What is a computer, really?